Hello, it's Controlbyte here. Everything what you need to know about programming, automation, and robots. Today, we will show you how to create a sequence for an industrial machine, and we will show you how to create a program for this sequence in TIA portal environment. Here on your screens, you have a factory I/O scene with pneumatic actuators and program for PLC. Hey, Jacob, how are you?
Hello, Matthew. I'm fine, thank you. Welcome to our viewers on right on the chat. Uh, who who are you, and what do you want to learn today? What would you like to learn from us?
Yeah, of course. Just write on the chat. What
Say
are your
hello.
expectations for this live stream? And let's get started with our topic. So let's get back to our presentation. Hmm. Here we have a plan of our live stream. Firstly, we will show you a simple graphed diagram. So this is a diagram where we can plan our sequence for the machine. Okay, so this is a graphical representation of our program in some cases, but also GraphSet is a programming language, and you can use this language. And next, you can download the program directly to our PLC. Okay, so we will think about that, how to create a sequence for industrial machine, and we will plan a sequence for 3 pneumatic actuators. We'll use some tools for PLC programmers. Um, we can draw a diagram for our sequence on the paper in our notebook, or we can use um, another tools in our browser, and we can create a sequence. What's more, we will work in a TIA portal from Siemens company, and we'll use a simple factory I/O scene. Factory I/O is a 3D simulator for virtual factory. So your project is a sequencing program for pneumatic actuators. Stay with us. You will learn how to create such a program. Of course, you can use a YouTube chat and ask questions here. Okay, so we have people from Philippines, Pakistan, Saudi Arabia. Welcome on our channel. Let's get started. For new subscribers, we are Controlbyte since 2019. With Jacob, we teach how to program PLC's industrial automation branch. So right now, hit the like button, subscribe our channel for more automation and robotics content, and ring the notification bell to stay informed about our new videos. And okay, of course you can um, write here on the chat where do you come from and what do you want to learn. If you want to learn PLCs, just type it here on the chat. And who are we? What we do in Controlbyte company? We deal with machine and automation system design, and we have established an online educational platform for aspiring engineers, PLC programmers. Our specialization is programming PLCs and robots. We design of control systems. We deal with machine safety systems, data acquisition, and what's more, we know a lot about IoT, Industrial Internet of Things. What we do such things like here on the slide. We can program a robot, and we can deliver the stand and the machine to the factory. We collaborate with the best. For example, Lenza is a manufacturer. They deliver the best drive systems on the market. Tark is a manufacturer for distributed systems and sensor, and Viland deals with safety systems, safety devices for machines, industrial machines. You can find us on LinkedIn. Just type Matthew Krantovich or Controbyte, and we can get in touch there. We post a lot of content for automation and robotics. Very helpful content for young engineers. We have a lot of courses on our online e-learning platform for Siemens in ladder language and STL language, which is text language, and more content. For example, here we have courses in codices for building automation, object-oriented programming, and specialized courses for motion programming, fundamental of automation design, and many more. You can learn on our learning platform. Here's you, and you need only your computer and some spare time. We have support on our Discord channel, and we organize live meetings there. Okay, let's start with our topic: how to create a sequence in ladder language and STL language, which is text language for PLCs. Maybe firstly, let's go to the Factory.io, and Jacob, you can show our viewers how it should work, and then we
Yes.
go to create a project for a graphical representation of our sequence.
Okay. Let's start with the basics. Every automation engineer had to program a pneumatic actuator as his first programming task. Here you can see some tags, some variables regarding the sensors of the actuators, and here you can see some tags regarding the outputs of our system. Okay. A pneumatic actuator is generally a simple device. It consists of two sensors and one or two controlling signals, coils. Okay, I will show those tags on the screen. Here you can see a control signal for this actuator. If I force the signal, the actuator extends its piston, and as you can see now it is in work position. If this signal is off, it is in home position. So you have one Boolean signal to move this actuator front and back. Okay. As I said before, there are two sensors. One, this is back limit switch, and in the front, you can see front limit switch. If it is highlighted in yellow, it means that this signal is in high state. So now the piston is not extended and it is in home position. Back limit is activated. So if I force this sensor, this signal will be true. It will go to high state. So generally a simple device. It is commonly used in many automation systems because it's really simple to control. You don't need some extra numerical control systems or controllers for those actuators. You have one coil or two coils. It depends on the valve that is used to control this actuator, and usually two sensors. Okay.
So what will be our task? Our task is to create a sequence for these three actuators.
Yeah. Our task will be to move those actuators according to this scenario. We'll program 3 or 4 steps. Here you can see this sequence where minus means that the actuator is in home position, plus means that this actuator is extended, it is in work position. So our task will be to write a program that will work according to those guidelines.
Okay, so here you have, Jacob, 5 steps. Step number 0, step number 10, and many more. So we can create a graphical representation of this sequence. Here I use an app in my browser, and I create such a diagram here. I can add some steps here, and here we have initialization step number 0. As Jacob said in a second before. And in the step number 0, all actuators are off. And if you want to go to the next step, we need to press a button to start a sequence. Okay, so here we have transition between step number 0 to step number 10. And in the first transition between step number 0 and 10, we press the start button, and all actuators are in the home position. So we're back, okay? And then we go to the step number 10, and the first actuator coil is set on, second actuator coil is off, and third actuator is off as well. So Jacob, maybe you can explain these 2 steps and 1 transition in the program.
Yeah, of course. We have some new viewers. Hello
from Ser-
from Serbia. Yeah. Hello. Nice to see you.
Nice to see you.
Ioannis, our students from Greece. Hello. Nice to see you, Ioannis.
Nice to see you.
Okay. So let's start programming. You can program sequential system with PLC using almost every programming language. Some of the programming languages are dedicated for sequential systems, some not, but you can also write a program in those languages. So let's start with dedicated language for programming sequence. It is called Graph. Graph language is only available for advanced Siemens PLCs for 1500 series. So if you use basic Siemens PLCs like 1200, you cannot use this programming language. This programming language looks just like the graph that, just like the diagram that Matthew has showed you. You just build a diagram using ready-to-use blocks. It consists of steps, transitions, and you can program some extra configuration of steps. Some of them can occur in the same time in parallel. Some of them will occur in a sequence. So here you define steps. If you step into, for example, step 1, you can put some code in a ladder diagram. Here you can program an action, and you can program condition for transition. So as you can see, this is just like the graph set diagram. Graph set is international standard for designing sequences for automation and robotics.
So you can design such a diagram here in TI portal, and you can download it to the memory of PLC. This is a programming language, and you can also just draw a diagram on your own in different software to visualize your sequence, and this is only for you, and then you can program in ladder or text language. Okay, here we have I think a guy from France. Bonjour. Bonjour.
Hello from France. Hello.
Hello.
Welcome. I think that you're asking about CPU 1200, if you can use graph set diagram. No, you cannot. For 1200 CPUs, you can only program in ladder, FBD, and SCL. Okay. So let's move on to a simpler programming language, which is ladder. We'll write some sequential program in ladder logic.
Yeah, we would like to focus on the basic language for automation programmers. which is ladder, and we teach this language first. This is the best way to start, and our channel is for beginners mostly.
Yeah. So I have declared two functions, one function in ladder, the other in SCL. Here is the code that was moving this factory IO scene a few minutes before. So this sequence is programmed in SCL, in textual language. And now we'll program from the scratch the sequence, the same sequence in ladder logic. So take a careful look, make some notes if you want to download this sequence. You can enroll in our entry or premium course, and we will publish all those materials on our e-learning platform. Okay, let's start. So here I have inserted an SCL network where I can write some SCL code. And as you can see, I have commented this code just to have this code, this nodes near me while I will be building my sequence. Okay, the first step will be to declare steps in our system. So in our system, we will declare steps with Boolean variables. So for example, step number 0, initialization. Okay. Definition in global memory. Perfect. As I said before, every step will be declared on different variable. Okay, maybe step number 3. You may wonder why I declare steps with interval of 10. It's step number 0, 10, 30, maybe 20 will be also useful. Okay. In automation and robotics, we usually declare steps with interval of 10. Why we do this like this way? Because if you want to modify your sequence, you can easily add another step. Between 10 and 20, you can declare 9 different steps, and you can modify your sequence easily. If you would use only like 0, 1, 2, 3, there will be no simple number which you can use to add auxiliary steps. So we usually declare steps like 0, 10, 20, 30, and so on. Okay. Step number 0 is initialization step. According to this step, all the actuators should be moved to home position. This step will be activated during the first call of our PLC, during the first program execution. I have to check if I have declared the proper tag. Okay, let's see. Okay, I have to enable use of system memory byte, and now I can use first scan, first cycle bit. Perfect. Okay. Now let's move on to code transition between step number 0 and step number 10. This will be setting condition for step number 0. I can actually, okay. And now we will use a pattern to structure our code for building a sequence. So firstly, I have to check if the step is activated. If step number 0 is activated and the condition of the transition is fulfilled, it will activate step number 10 and deactivate step number 0. Okay. So here, between step number 0, normally open contact, and setting and resetting coil, you have to insert a condition of your transition between step number 0 and step number 10. In our system, this is home position of our actuators. So I have to insert normally open contact of my 3 actuators. Okay. And the last normally open contact will be with, with push button start. Perfect. Okay, so this is the scheme for the transition between step number 0 and step number 10. We'll use the same code for the next transition between step number 10 and step number 20.
Okay, so let's compare that with our diagram here, which we have here, and let's analyze it. Okay, so in the step number 0, all actuators are off, and Jacob just has just written that in TA portal. And here we have transitioned to the next step, to the step number 10, and Jacob just wrote a program to check the condition of this transition. So we have a push button, and all actuators should be in home position. Okay, and then in the step number 10, all actuators coils. In the step number 10, the first coil of the first actuator is on, and actuator number 2 and number 3 is, and actuator number 2 and 3 is off. And based on that graph, you can easily create a program. So firstly, I suggest you to draw that on a paper or in the app, browser app. Okay, let's go back to our program.
Okay, so having the steps declared, you can now copy this structure for another transition, and now you have to just switch the names of the variables. We have a transition between step number 10 and 20. So here we check if this step is active. And here we have to set step number 20 and reset step number 10. Okay, and here you have to assign proper conditions for this transition. So here we have to check if actuator 2 and 3 is back, okay, and actuator number 1 is in work position. Perfect. So as you could see, I have changed the first transition. In just 30 seconds. And this will just work fine. So let's program another step. And as you could see, we have not programmed any outputs yet. Why is it? I will show you just in a minute. Firstly, let's just program all the transitions. And after this, I will show you how to assign outputs in this sequence. So step number 20. Okay. And the first one should be in work position and the third one in work position.
So in the step number 20, all actuators are on. Yes?
Wait. Step number 20.
And 30.
Okay, so step number 0, step number 10, step number 20. Yeah, step number 20, all actuators on. So here all the are in the back, this one in the front. So here all the actuators should be in the front. Okay. Now the second one should be in the back. Okay, this I have to declare step number 40. Okay. And the last transition is going back to home position. So from step number 40, we'll go to step number 0. Okay. Step number 0 set. Step number 40 reset. Perfect. Our sequence is ready. Now we can check if the transitions work fine, and then we'll assign outputs to this sequence. Okay. Okay, I have to reset the CPU. Okay. Now step number 0 is activated, and these 4 normally open contacts are conditions of our first transition between step number 0 and step number 10. To activate step number 10, I have to press the start button. I have pressed the button, and now step number 10 is activated. Now our system is waiting for those 3 conditions to be fulfilled. So now the first actuator has to be extended, has to be moved. So I will force this coil manually, and the first actuator reached the front limit switch, and now step number 10 was deactivated, and step number 20 is active.
So on the graph, it's look like that. Here we have step number 10. The first coil, the first actuator is on. The second actuator is off. The third one is off as well. And then we have a transition. And when the sensor in the front of the first actuator signals the position, then the condition is fulfilled and we go to the step number 20. In the step number 20, all actuators are on.
Yeah. In step number 20, we have to activate all 3 coils, and okay, I will do this now. Now the coils are activated and the sensors are moving to the front. Front limit switches were activated as well. And now, as you can see, step number 30 is active. So now I have to move back sensor actuator number 2. And step number 40 is active. And now I have to move back the other actuators. And
Okay, so
yeah,
and
the
we go
sequence
back to
ended.
and we go back to the step number 0. So on the graph we have like something like that, but we have a transition from step number 20, and we wait when all sensors in the front of all actuators signals the position. The transition between step number 20 and 30 is fulfilled, and we go to the step number 30. In the step number 30, actuator 1 and actuator 3 are on, and in the middle, actuator 2 is off. Then we have a transition to the step number 40. And in the step number 40, all actuators are off. When all sensors in the back signals the home position of all actuators, we go back to the step number 0 and we start the sequence once again. The operator should push the start button and the sequence start once again. Okay, that's all for this graph, and let's test our program, live program.
Yeah, we have to program the outputs in our system. Previously, I have used the forcing function in factory IO, and now we will add coils in our program. Take a careful look. Here you have only the transition, only the conditions and for setting and resetting steps. I have not inserted here any coil yet. And we have to program this at the end of the code for the sequence. Outputs are really not relevant in the systems regarding the steps and the transitions. Outputs can be programmed at the end of this sequence system. Okay, so while programming a sequence, we can use flip-flops. I will assign actuator coil for actuator number 1 here. And here I have to assign conditions that will set this coil and reset this coil. So now I have to quickly check for actuator number 1. I have to look for the steps that this actuator is set and reset. So for step number 0 and step number 40, it should be reset. Okay, and this actuator should be extended in step number 10, 20, 30. Okay. Perfect. We have the first actuator programmed, and we'll use the same scheme for the other actuators. So now I have to use another flip-flop. Actuator coil number 2, and I will do the same with the second. Actually, this one is extended only in step number 20, so we can simplify this assignment. Okay. And the third actuator will be activated in step number 20 and 30. So we can also use a flip-flop here. You can find set reset flip-flop or reset set. You have to use proper flip-flop. If you are curious about flip-flops, you should watch our previous video from last week. Okay, so here we set this output in step number 20 and 30. Okay. And reset conditions is step number 0, 10, 40. Okay, and the output actuator coil number 3. Let's download this code to PLC and let's check if we did everything right. So let's see. Okay, our sequence works okay. If I would make a mistake, for example, in code for coil assignment, our sequence would stuck in some step. For example, I can delete this normally open contact, and let's see if our sequence will work properly. I have erased step number 30. Okay. Okay, and let's check now. Okay, I have chosen the wrong example because this coil is activated throughout step number 10, 20, and 30. So I have to, for example, change this to 20 and 10, 20, 30. Okay. And let's start the sequence now. Okay, I will reset. Okay, now we are in step number 0, and if I press the start button, it will go to step number 10, but I have made a mistake here. I have not assigned step number 10 to activate coil 1, and our sequence just stuck. So I have to add here step number 10, download to PLC, and instantly our program is working fine. Okay, so in this way we can create a sequence in ladder logic. As you could see, it is really simple. You use a scheme for transitions and for output assignment. Now we can show you another way of programming sequence. It will be programming in SCL, Structured Control Language, for Siemens PLCs. Here I have two functions blocks, one in ladder, the other one in SCL. As you can see, they work just the same. SCL block is working continuously with the sequence, but the sequence is programmed in textual language. Here we use case instruction to structure our code. Case instruction consists of sections. Here we have section number 0, section number 10, section number 20, section number 30, 40, and else section. Case instruction is perfect for programming a linear sequence because in this instruction, only one section can occur when this instruction is executed. So you define different steps in different sections of this instruction. And in every section, you define code that should be executed in this step. It's a
Maybe
little bit,
we can write it from the scratch in another live stream.
yeah.
Okay, but okay. So maybe we can write on another live streaming that we it would be okay. We can create this sequence in STL. You can write on the chat if you want that. If you want that, just hit the like button down below the video, and we can do that different time in different time. Okay,
Yes,
so I
but
think. Mhm.
Mhm. I wanted to show you different types of programming sequence for Siemens PLCs. And
Yeah,
as you can see, we coded this in graphical language. We can code this in SCL, in textual language, and you can also use a graph programming language for Siemens PLCs if you program S7 1500 CPU.
great. So the sequence work perfectly. If you want to write this program on your own, just join our courses down below the video. We will give you templates. You can download this template to your computer and work with us on our e-learning platform. We will show you from scratch, from zero to hero, how to create such a sequence in ladder language. And in another courses, we will show you how to program it in a text language STL. So if you want to do it, just enroll in the course down below the video. So Jacob, thank you for your work. We will see on a next live stream. Maybe in next week we will show you more sophisticated programs with sequence for industrial machines. And that's all. See you.
Yeah. Thank you for watching. See you in the next week. Bye.
Thank you a lot.